You are welcome to my YouTube channel. Our topic for today is differentiation. Let's recall some techniques of differentiation. We have the product rule, the quotient rule, the chain rule, the power rule, and so on and so forth. In the course of this work, we will be applying some of these rules. Now let's look at some basic functions and their derivatives which we shall use later in the course of this work. Now, if y is sin x, its derivative is cos x. If y is arctan x, its derivative is 1 over x squared plus 1. If y is arc cos x, its derivative is minus 1 over square root of 1 minus x squared. Let's look at some worked examples. If y is equal to arc sine, 1 plus 2 sine theta over 2 plus sine theta, find the derivative of y. Solution: we are asked to find the derivative of y if y is arc sine 1 plus 2 sine theta over 2 plus sine theta. Now, in this case, you are going to replace u with 1 plus 2 sine theta all over 2 sine theta. Then you differentiate u with respect to theta using the quotient rule. Now, when you simplify the numerator, you are going to have 3 cos theta. Hence, the u d theta will give you 3 cos theta over 2 plus sine theta squared. Now, compute the derivative of y. You are going to have that y prime will be 1 over square root of 1 minus u squared times the u d theta. Now, simplifying the square root will actually give you 2 plus sine theta squared minus 1 plus 2 sine theta squared all over 2 plus sine theta all squared. Now, by the time you compute the numerator, you are going to have 3 cos squared theta. Hence, square root of 1 minus u squared will become square root of 3 cos theta all over 2 plus sine theta. Now, by the time you substitute back, you're going to have that y prime is equal to square root of 3 all over 2 plus sine theta. Recall that log x base e is equal to the natural logarithm x. And for any positive number a which is not 1, log x base a is equal to log x all over log a, which is in its natural logarithm. Let u be a differentiable function of x, then the derivative of ln x is equal to 1 over x, and the derivative of ln u is equal to 1 over u times du dx. Now, let's look at this worked example. If y is equal to log base e of the square root of 1 plus s squared over 1 minus s squared, we should find the derivative of y. Solution: we are asked to find the derivative of y, which is the y dx. Now, if our y is the natural logarithm to base e of the square root of 1 plus s squared all over 1 minus s squared, by the time you simplify the logarithm, you are going to have that 1 over 2 log 1 plus s squared minus log 1 minus s squared. This is indices. Now, by the time you differentiate the y dx, you are going to have 1 over 2 d dx log 1 plus s squared minus d dx log 1 minus s squared. When you compute the derivatives of the logs, which is the one on the 1 plus s squared and 1 minus s squared, you are going to have the following there, which is 2x over 1 plus x squared and minus 2x all over 1 minus s squared. By the time you substitute, you are going to have x in bracket 1 over 1 plus s squared plus 1 over 1 minus s squared. By the time you simplify the fraction, you are going to have that y prime will be equal to 2x all over 1 minus x raised to the power of 4. Now, we are going to look at differentiation from parametric equations. In general, if y is a differentiable function of t and x is also a differentiable function of t, then dy dx will be equal to dy dt divided by dx dt. Let's look at some worked examples. If x is equal to t raised to the power 5 minus 4 t raised to the power 3 and y is equal to t squared, find the second derivative of y. Solution. We are asked to find the second derivative when x is equal to t raised to the power 5 minus 4 t raised to the power 3 and y is equal to t squared. Now, taking the first derivative with respect to t, you are going to have 5 t raised to the power 4 minus 12 t raised to the power 2. And taking the derivative of y with respect to t, you are going to have 2t. Now, our first derivative, which is dy dx, will now give us 2t over 5t raised to the power 4 minus 12t raised to the power 2. Now, t is common both on the numerator and the denominator, so you factor t squared out. Then you're going to have 2 over t in bracket 5t raised to the power 2 minus 12. Compute the derivative of dy dx with respect to t in the second time. You're going to have d dt times dy dx will give you minus 2 times 15t squared minus 12 all over 5t raised to the power 3 minus 12t squared. Now, the second derivative will now give us minus 2 times 15t squared minus 12 divided by 5t raised to the power 3 minus 12t squared all over 5t raised to the power 4 minus 12t raised to the power 2. Now, factor t on the numerator and on the denominator and substitute. You're going to have that the second derivative will be equal to minus 2 in bracket 15t squared minus 12 all over t raised to the power 4 in bracket 5t squared minus 12 raised to the power 3. Thank you.